and welcome back to Get Kafka-Nated, the show where we explore the fascinating world of Apache Kafka, from architectural deep dives to the people that make it all happen. I'm Hugh, your host, and I'm excited to be back with you for the first episode of a brand new season. A quick reminder before we start the show, our free tier for Apache Kafka competition is still running, so to be in with a chance of winning $5,000, check out the link in the chat and show us what you can make with free tier Kafka. Today, though, we're going to be diving into Fluss, Lakehouse, and the future of streaming. I'm delighted to welcome Giannis, Principal Streaming Architect at Viverica and Apache Fluss PPMC member. Welcome to the show, Giannis.
Hello, man. Thank you for having me.
It's great to have you here.
I feel so honored for being here and opening this new season and year with you.
It's a real treat to have you here. Yeah, I'm super excited. My first question, coming back to something from my introduction for you there, what is PPMC for people who aren't familiar with that? And how did you end up on the Fluss PPMC?
So PPMC, for those that don't know, is basically similar to the PMC under the Apache. When a project is under the Apache Foundation, but while it's still in the incubation period, it hasn't graduated yet. So Fluss for me was I started with Fluss right the moment it was open source from day one, and I started contributing to the project and helping grow the project. So for this, I was part of the committee, let's say, become part of the committee when we actually donated the project into the open source and the Apache Foundation, which happened in June last year.
Very cool. I think the P in PPMC stands for podling as well, if I'm not mistaken, which is very cute.
You have no idea you have no idea how confused I was in the beginning. I mean, yeah, I was like, I knew PMC, now you add me PPMC. What is this? What's the difference? It just blows your mind. I don't know.
It's kind of like an ATM machine thing kind of going on there, right? Like, we'll just add more letters.
And to be honest, if someone asks me, I'm still not 100% sure if I give the right answer. This is just how I translate it.
So Fluss is, as you say, it's this like Apache project. It's incubating. You're part of the team that donated it to open source. What actually is Apache Fluss, and like what problems was it built to solve?
This question is so simple and so tricky at the same time. So let me see. I mean, I can give you the simplest thing, like what is also written in the documentation, like Fluss is a columnar streaming storage, but I don't know how much sense it makes, or how much people can actually understand. Okay, great. How is it useful for my business? What I can do with that? And to actually understand Fluss and where it's coming from, I think the best approach here, as an architect, it is to wear my architect's hat and do a revision in terms of how we are building modern streaming and real-time architectures. And basically, the most important thing, and I'm working at Viverica, I've been working with Apache Flink for years, and the essence of Flink and lots of the work we are doing is all about stream and batch unification. So these are the principles based on what we are building and the architectures and everything around our work in general. So if you go back and for the last decade, how we have been building modern streaming data platform systems and architectures in general, it looks something like this, more or less. You have Kafka in the ingestion, and in many enterprises, it actually is the central nervous system. All the data flow there through different systems. And what are those different systems? They are basically databases and OLAP engines. They are caches like Redis. These days we have vector databases. And we also float all that data in Lakehouse, right? So basically, and you also, of course, have stream processors like Flink that continuously do some kind of computing and take actions. But if you think about it, and this is the approach, what we try to do there is basically provide an alternative, if you will. Basically, the whole need started in terms of how we could provide an actual streaming storage layer that will allow the stream batch unification for Apache Flink, because you might see a lot out there on the market that Kafka and Flink are a great combo. On the one hand, it's true because one complements the other. On the other hand, you have no idea how much Kafka actually causes Flink to underperform. It's not about Flink, Kafka being bad. It's just about it was created for transporting messages, right? Like getting messages from point A to point B. At the same time, a popular trend these days is the Lakehouse. I mean, if you noticed, what we are actually doing these days is we try to, let's say, centralize our data again on the Lakehouse, and you have open table formats like Iceberg that actually do what? It allow you to structure your data on the data lake, and it's actually shared storage, and you can add query engines on top. Now, what we actually end up being doing with Fluss is actually doing the same, but by providing a hot layer on top of the lake house. And the difference there is now what? Instead of having your data just flow through Kafka to many different destinations, what we try to say now is centralize your data into Fluss, because basically right now, instead of needing Kafka and needing an external database and all App Store to basically serve the data and use something like a key value store or low latency cache like Redis, everything is basically centralized to the same streaming storage layer. So you have just one single system. Um, and the single architecture centralized that has Fluss as the hot layer and open table formats for the cold and warm layer. And basically, instead of topics there, because that's the other funny part. If you notice that for all the data systems in the previous architecture we mentioned are data systems, and they have what abstraction? The table. And Kafka is the only one that has the topic as abstraction. So what if we could use streaming and model it as a table abstraction as well? So this is what we did with Fluss. This is basically how we simplify the overall architecture. And what this means in practice is you have a single table abstraction, and you have the hot layer sit on Fluss. The cold and warm layers get tiered on the data lake house. And this is where it gets interesting. And this was not the original intention, but this is where we are ended up being. We had lots of requests, and we started observing lots of use cases around feature stores and the centralized place for modern data and AI. And why is that? Because Fluss actually added support for multimodalization, which is really important these days. Text, images, videos. So it gives you the power because it also supports a row-oriented data store. It has columnar storage and also vector storage. It's uniquely positioned to act as a centralized storage layer for all this kind of data. So this is where we are at, but we are still in the early days. But this is basically what we see as the future of streaming, and what we started like 2 years ago with all this stream house architecture. It all began basically with a table as an abstraction, and started with Apache Pymon the day, with a goal to bring streaming onto the data lake house. And Pymon is still an excellent choice if you want streaming and near real-time latencies, because if you don't need low latencies, even Fluss is a cluster, right? It's an overkill. You just get a library with Flink and you get that onto your data lakes.
So it's fair to say then that Fluss is kind of a consolidation of all of the components that make up that kind of stream house architecture.
And this is what I've been thinking about. I don't know if it makes sense, but this is something that during my holidays, because I have lots of time to think. Right. If you notice, this is an analogy. I don't know if it makes sense. I haven't think it through, but if you think about it, we started having everything centralized back in the Hadoop days, right? Everything was Hadoop, and we built an ecosystem around that. Then we decentralized everything around with Kafka, and now these days with open table formats, we try to centralize everything again. We also created Fluss. So I don't know if it makes sense, but to me, it feels like we're going into circles. And I hope these days, because for me, Fluss is actually our way towards the stream batch unification. Because if you also remember my presentation at 7 Deadly Sins, this is what I see as the core foundation. I'm not an AI guy. I only know little about the AI. I'm just trying to catch up. But for me, this is the solid foundation based on all the experience I have for real-time ML pipelines, a centralized repository for your data. Let's see. We'll
Awesome.
see.
I really like that as an explanation. That's really cool. You mentioned Paimon in there. I was interested to ask you a little bit about that as well. So, as I understand it, you've worked with Paimon a bit and also with the kind of broader Lakehouse ecosystem. For people who are trying to understand that landscape, how do you see Paimon as of today versus maybe like Iceberg coming in as being this all-encompassing standard for sort of the data lakehouse?
So this is an extremely interesting question, and there are lots of approaches to this. So if you ask, there are some basically really large scale companies using Paimon right now in the market, but at the same time, I don't know how many use cases, in terms of the wider adoption, we'll see. Because Paimon, as I said, has, in my mind right now, a really, let's say, niche market in the sense that you want to introduce streaming onto your lake house and you have near real-time use cases. Now, in almost all the Paimon adoption stories, 4 out of 5 contain Iceberg inside. And what this means is basically because Paimon is streaming first and has lots of benefits for the stream batch unification architecture and with things like, basically I want to set the stage with the one concept I introduced lately. It took me like 2 years to find the right, let's say, framing for this on my mind. So, in the lake house architecture, the medallion, you have this bronze layer, silver and gold, right? And when you're working with table formats like Iceberg or Delta Lake, for example, you typically have your bronze layer for the ingestion, and then the other layers is just recomputations with workflow, schedulers, batch jobs, these kind of things. For years, I was trying to see how to express it with Paimon. And my answer to that was data continuity. And I write about this. I started the whole substack to write about these things. So what this means in practice is basically along all those different layers, data just flows from bronze to gold. It's all streaming. So with Paimon, companies use it to achieve this stream batch unification and basically migrate. This is what people don't understand about Paimon. It's not just another table format. It's about migrating Kafka and Flink workloads to Paimon and Flink to avoid paying the cost of Kafka. You can think of it like brokerless Kafka. Sorry, not diskless Kafka. Sorry.
Diskless Kafka, yeah.
But with the difference that you get also analytics out of the box. So change data capture use cases with automatic schema evolution at really low latencies, like seconds to minutes. Streaming materialized views, data continuity to chain all these different layers together. These are use cases for Paimon. But here's the interesting part. At some point, and for Flink users and streaming engineers, Paimon makes all the sense of the world. Like if you ask any of these users, they will tell you, I have heard this phrase continuously. Paimon's like iceberg on steroids, and it's amazing. If you see Paimon, you cannot say. And honestly, this is a challenge for everyone out there that does that. Try using Paimon for a month, and if you want to choose a table format, please let me know because I highly doubt you will. It's But again, then there are other teams that enter the space because a company is an organism. There are scientists, there are analysts, there is the whole ecosystem. There is BigQuery, there is Athena. Iceberg has the ecosystem and also has the community, people that actually use it. So what these companies actually that adopted doing 5 out of 5 use cases is basically they use Paimon with the Iceberg compatibility. This is the cool thing with Paimon. It's similar, like you see projects like Xtable, which try to unify open table formats. Paimon has built-in. It has Iceberg compatibility, it has Hoodie compatibility. It also supports the Lance data format. So if you want also to do real-time AI and vectors, it's there. But no one knows about these things. That's the problem with Paimon. It doesn't have a community. That's the issue here. Yeah, downstream, Iceberg is always needed. It's always there. So, for example, Yelp is using Paimon, but is using the Iceberg compatibility to integrate it with Athena. Unity 3D, for example, use heavily Paimon, but they also use the Iceberg compatibility to integrate with BigQuery. These are some examples to show that Paimon is cool, but Iceberg is always there. I don't foresee it going away. And the other part with Iceberg is that basically Paimon was created to solve lots of issues with streaming and updates, but with Apache Fluss, because it actually acts as a hot layer, it handles the updates, it handles all the data freshness for Iceberg. So all these problems basically with Iceberg, Fluss solves for those. So that's another thing.
Amazing. So yeah, Iceberg is everywhere, and if your data is already in Iceberg, don't be afraid to try Paimon because it's awesome, even if it is perhaps a less popular tool than others, and Fluss is
And
promising to
it's
do even
mainly,
more.
and it's basically more, let's say, promoted and used within the Flink community, because for a Flink, no, so for a non-Flink user, because chances are, I think Flink is compared to the other engines like Spark or I don't know what you name it, Athena, BigQuery, Starox, whatever. It's streaming first compute. So there are different things there. The main adoption I see with Paimon is mainly along with the Flink community and some Starox users. Outside of those, again, since there is no community, there's also no one to promote it to other communities. So we'll see where all this goes.
It's going to be very interesting. But yeah, I love the promise of Fluss there to combine a lot of these really cool ideas.
And
I love
this is also the awareness I'm trying to raise, because these days, and the same might go for Fluss, right? I'm opinionating this technology for specific reasons, but we focus so much on the technology instead of what this is what I observe a lot with Iceberg and Kafka these days. I'm missing what problem you're trying to solve technology. Like, okay, somehow Iceberg became, let's say, really popular, and everyone asks with Iceberg. But what is it actually you're trying to achieve? Have you evaluated other table formats? And the reason I'm raising this question is that in my world, at least the streaming world, I get this question like 3 out of 5 times for people going with Iceberg. They ask me, how can I do this? I'm like, it's not supporting Iceberg. It's a Paimon problem. So I'm trying to understand how people actually evaluate technology and how they choose the Iceberg. And the other interesting part is I see many times engineers to the staff and principal level saying Iceberg is a no-go for our use cases. And then you have the management that says Iceberg is the popular one. We'll go with Iceberg. And this is where everything feels disconnected. Like, do we try to just introduce something because it's popular, or are we trying to solve a problem? And in the long run, what does it mean for the business? So yeah, there are lots of. It's an interesting industry, and sometimes it's fun.
Yes, I feel that. I'm slightly distracted by Jan shouting "hot layer" in chat like he's watching a sports game, which I kind of love. I really feel you on that last point around like the general case of something like Iceberg, which is like broadly applicable, but maybe isn't necessarily going to have some of the specialization that you need for certain problems, versus like the specialized case of an open source project that's going to solve like your problem in particular super well, but maybe it's going to make it harder for you to talk to like the rest of the business who do things in a very particular way. Like I always think that's such an interesting problem to explore. One area I think that we're touching on here is this kind of ever-present sort of streaming versus batch debate. And I think it's very clear that the position that Fluss takes on that is like, why not both? You mentioned there the actual architectures that people are bringing in to try and solve like what are the actual problems that people are solving by making these kind of choices, right? So my question would be, what kind of architectures are you seeing out there in the real world for teams that actually need this true unified streaming and batch to solve the problems that their business are facing? And what kind of problems are they trying to solve with unified?
So this is where things get interesting, and I'm going to be blunt here and say that most of the problems comes from the tech marketing that there is out there. And the reason for that is you have the large scale companies that actually go through into evaluating in detail every single technology. And I'm not going to say this can be any technology, right? Forget for a minute, forget Kafka, forget the Flink, forget anything. These companies actually evaluate everything and know what works and what doesn't. So if you try and pay attention to those large scalers like Alibaba, ByteDance and TikTok, LinkedIn, Unity 3D, Yap, these are some Xiaomi, these are some companies that come in mind. They adopt this kind of technologies because it's also at their scale actually provide true stream batch unification. Now, in our world, let's say, because I also happen to work with a lot with the Chinese world and the Eastern world. In this world, we are more on the marketing side. Like we see lots of Kafka, we see lots of Iceberg. So we say, let's put these two together and say stream batch unification. Stream batch unification, as I mentioned in the beginning, for me it's primitives. It goes back to the core primitives we want to use, and this is why I advocate a lot about. And these are all the things for anyone interested. I'm writing it. I started my Substack like 1 month ago, writing about those. Comes to the table as an abstraction, because when you have streaming on the one hand, which is a topic, and you basically name this thing a Kafka stream. It's a stream, right? On the other hand, you go to the table, which is also, let's say, the Lakehouse, and the definition of Lakehouse is batch. So you have stream and you have batch. Just because you create an integration layer, and it's also on the bronze layer, let's say, that just offloads the data or writes them from the stream layer to the batch layer. This is not unification. And for example, if I add a query engine later, like let's say Starbucks, I need to run queries. I can't query Kafka. I have to write my data into OLAP. So by definition and at its core, this breaks the semantics. On the other hand, if it's, let's say, I mean, you might have also noticed lately this trend with the streaming databases, right? This is also what they try to achieve: stream and table, a single abstraction. The difference there is, and this is why I like Fluss more, is that compared to the streaming database, these streaming databases are also, the storage is coupled, like it's their compute, their storage. As I mentioned at the beginning, Fluss is open, a shared storage like Iceberg, and it also supports vectors, row stores, columnar store, everything. This is the difference. But if you notice over the last years, this is the difference with the industry, and this is why I also personally got really involved with Fluss, because okay, for the last decade myself, Kafka put food on my table for years, like literally for years. And I did Kafka, I did Pulsar, and I did Red Panda. And then you started seeing other things. You saw AutoMQ, you see Buffstream these days, but they all share the core primitive, the topic. And the topic is great when you want to move data. But then I got into data analytics. I'm like, Fluss clicked for me, like, oh my God, this is the future. And I hope more people say this.
That's a really interesting point. Yeah, I like that as a way of thinking about it. This is something that we've heard so much over the last year, talking about things like diskless Kafka and Iceberg, where it's this idea of the topic and table unification. You say like, yeah, integration, true integration runs deeper than just table to topic.
Exactly.
Topic
and
to
this
table.
is what I try to argue on my posts, and many people might disagree. But if you put these things on paper, and we have also these, actually, if you put all these things on paper, everything makes sense. It's in the production that breaks, and this is what we need to go back, and we need to stop. And this is why I also, in my post, I try to keep it generic, not talk about Fluss or Kafka or anything. It's the abstractions that matter, and we need to build on these abstractions. Why? Because if we want to enter the next generation of data systems, which is AI systems, for me, we need to also take this different approach. Why? If you think the quote that was everywhere last year is that AI needs streaming data. But think of it. Let's zoom back. And again, I'm not an AI expert. I'm also exploring these areas myself these days. Let's go back to the Kafka approach, a nervous central system that just feeds everything with fresh data. What do you do with that fresh data then? And I will tell you what, based on what I'm observing. Everyone says use Flink for AI, which means aggregating the data again with large joins, everything from external systems, with extra latency, with systems that might not even work together in terms of compatibility because one is streaming, one is batch, just to collect all your data again. So why not use a centralized a centralized storage in the first place? Again, I don't have answers. These are, I told you, during holidays I have so much time, so I had lots of things to think about. Because
I would completely agree with that. Where it's like we talk about AI and streaming, and I'm like, if you're working with vectors or working with tabular data with models much of the time, then yeah, you don't necessarily want to be consuming directly from stream. You want to have your data prepared. So I think that makes a lot of sense to me. We had a great question from Jan actually quickly that I just want to squeeze in, if that's okay. So he had a question around Fluss Spark integration, which I think is quite cool. So how's the progress of Fluss Spark integration? And more on that, did you see a lot of interest in Fluss from Spark users?
This is so basically to address the first part. As far as I know, there is lots of progress there, and in the 0.9 release. But I need to follow up there about the progress. The Fluss Spark integration should be in place. There was lots of work that started months ago, but because the contributors couldn't continue there, it was stale. But now it was revived with full speed. And as I said, because our goal is to make Fluss a shared storage, we need an ecosystem. So we have Flink, we're adding a Spark and Trino, and the next for the plan is Tarox. We'll see. If more people use it, maybe it's easier to add more integrations. We'll see. Now, here comes the interesting part. I don't see interesting from Spark users yet, only because I don't think that Spark users know Fluss. Flink started from the Flink community, and in the beginning and the first months, we also kept it really focused on Flink. But then I don't think anyone. Then we started realizing the value and the potential, and we wanted to open it more. Now, if you ask me, and if you also see, let's take Spark structure, not Spark bots. Basically, I saw lots of interest in Fluss from companies that they want to break down silos because they had teams using Flink and teams using Spark, and they said to give us Fluss, breaks down the silo. We have the shared storage. Our engines can all use it. But what's the but here? I think it makes lots of sense from Spark streaming structured streaming users. Why? Because if Spark structured streaming also lives up to the low latency expectations they released a few months ago about the continuous mode, I don't remember how it's called, Spark will have one big issue, and this issue is large states, which Flink has worked years to solve. Now with Fluss, this is the other cool part. We promote the compute storage separation. So basically engines, whether it's Flink or Spark structured streaming, just focus on link compute, and all the states now are externalized and live on the streaming storage. So this means that if you want to run large joins, if you want to run aggregations, you don't need any states there. And this is huge not just for storage. This is huge because the main issues with stateful stream processing and for companies in general is business continuity. Because if something crashes and if a job needs to either scale in or out or it needs to recover, it needs to rebuild large states or distribute those states. So by having the states in the shared storage, the job just starts immediately. This is a huge benefit. And you see, we have how much 30 minutes right now, and you have me here talking about flows. So imagine someone that comes to flows, just this documentation. How do you enforce this message? This is my question. There is so much to tell and so much background someone has to have. And this is what keeps me, this is my job. This is what keeps me late at night awake. Like, how do I make this simple for everyone to understand?
That's so real. I feel that. That's a great answer, though. And I think it's really interesting to explore, I think the nuances of these different tools when it comes to bringing them together in a unified place, what things carry over.
Since we are here, if any Spark users or people from the Spark community sees us, please let's work together to help you understand and spread the word about the value of Fluss also in the Spark community. I think if there is one thing missing in that space, the Spark in Databricks is Fluss. Because they literally have everything else. There might be a few more, but yeah, I need to promote Fluss here.
That's very fair. One final question. I have a feeling I might know the answer. What would you say is the most underrated thing today in the streaming space? Like a tool, a concept, a technology?
The most underrated thing, and I will also go back to my Substack because I wrote about this Monday, last Monday, I think. It's about this whole stream batch debate and how everyone says that batch is good enough and that streaming is only for specific companies and for specific set of use cases. And the short thing I'm going to say there is that streaming is for machine decisions. That's my way. That's the way I like to reason these days. And batch is for human decisions. Batch decisions are easy to reason about. You can create reports. You can create everything. But if you truly want machine decisions, and if you're a business, and you tell me that you want AI into your systems, I can't hear you telling me you want batch is good enough. And not only that, you are a user. I'm a user of how many applications and how many services. If I see these services lagging behind, like I make a transaction in a bank and I don't see it reflected immediately, or I send money to a friend, or I get into Netflix, for example, and I'm scrolling there and I don't see the recommendations change based on what I'm saying. Or if I order something and I don't get constant updates, am I satisfied with that user with that user experience? Or if I go to airports, if those that say that batch is good enough, are they okay with this kind of experience? This is my question to them. Are you okay with that experience?
That's a really good shout.
The other part is that the streaming is expensive, and batch basically they just see Flink, they just see streaming as Kafka and Flink, let's say. Now, streaming is a matter of data continuity, as I said before. Like, what do you think is more cheap or expensive? Having database tables, what I said before about the data continuity, like being updated, running low on resources in streaming, and running incrementally, being updated all the time, and you have technologies like, as I said, Flink and Pymon, for example, or AutoMQ or other diskless Kafka technologies to support chip streaming, or doing all these manual operations for data coming in, these data swamps, let's say, because let's face it, these swamps, because you have to run large batch jobs. You have to handle the scheduling and have workflow schedulers to work 24/7. That's also something that they don't take into account. You need to learn batch jobs you need to run large batch jobs to reconstruct the same results again and again. Personally, from all the use cases I have seen people moving from batch to streaming, every single time it says reduced costs. So I don't know. The batch people say what? It's cheaper because on the one hand, I assume I have something running 24/7, a machine, and burns more money than having to spin up and close the machine. It's not like that. This is not the reality. How it works. And I'm not even gonna go down the direction of how all the schema changes break in batch mode, or how people you have analysts. I want data. Okay, let's wait 2-3 days until the data engineers are able to create that job that brings the this is cost. So there is way much rate. Anyway,
Great
yeah.
stuff. Great stuff. Well, you heard it here, folks. Streaming is underrated. Thank you for your insights today, Giannis. I think I could quite happily talk to you all day about Fluss, but thank you for this half hour. One quick thing before you go: if people want to find out more about your work or any of the blogs you've mentioned, where can people find you online?
So basically, I think first of all, I live these days on the Fluss Slack channel. They can find me on LinkedIn, and if they want to find more, they can also follow my Substack. So I write basically about all these things there. It started like 1 month ago, so yeah, I could use a bump if you guys like what you hear today here. Yeah.
Awesome. Well, folks, go check out Giannis's Substack, and thank you again for joining us. That was awesome.
Thank you for having me, doing me the honor to open this year with you, the season.
It's my pleasure.
Looking forward to more Kafka-Nated.
Good stuff. Well, thank you to everyone who also joined us live. Thank you, Jan, for the great questions there also. Next time, we'll be joined by Lakekeeper committer and co-founder of Acamo, Victor Kessler, for a conversation all about iceberg rest. If you've got topics you'd like us to explore, want to be a guest on the show, or have feedback on today's episode, please reach out to me on LinkedIn. I'm always happy to chat Kafka and Get Kafka-Nated. We're always looking for new voices and perspectives from the Kafka community. Thanks for listening, and see you next time.